Fiona got two boyfriends. You got two boyfriends. One's not enough. All right, so we're gonna talk about what we're gonna talk about. Okay, we're gonna talk about area between the curve. So this week, maybe test will be Friday because that's all the stuff we've done before. So it's area and volume, but this time we might have to do arc length, which is on BC exam. And we also had to responsible shell method. If not, Friday will be Monday, something like that. All right. So let's talk about area between the curve. We obviously know, like, how do we find, let's say, x squared, like, between, let's just say, between 0 to, let's say, 0 to 2, like this. Great.
Should it stop streaming or something?
I don't know, actually. Delete. All right. Anyway, so let me try this again. Take forever. Why is take forever? All right. I just say I want to find out this area here. Aiden, are you sleeping? Huh? Okay. So you want to find out this area underneath a curve. What are you supposed to do? Integrate between 0 to 2 of x squared dx, right? I don't need to do the math, but you should know how to do that. So that's just area under the curve. But what about between two curves? So let's just say today I have y equal to a function called, let's just say it's, give me a second. Let's just give you x squared plus 2 and y equal to negative x and x equal to 0 and x equal to 1. So I want you to find out the area between those those functions. So then you say, okay, well, first of all, you should sketch all these functions. Then you know where is it from, right? Yeah, all of them, yeah. So you guys should sketch this graph. For Aiden, you have to know the area between the curve. Just for example, if I have two functions, let's just say it's like this function like this. This is f of x. And this is another function says, let's say, g of x like this. And if you want to find out the area between here, basically is the top function area minus the bottom function area. Because you take this area of this whole thing, which is under the curve, subtract the white piece of area, and then you get the area in between. Does that make sense? Is that okay? So just top minus bottom. So in this case, if I were to sketch this graph would look like something like x squared plus 2. So it's going to be like this. And there's another function says negative x. So it's going to be like this. and the function is going to be this way. But they also have another function says from here to here. So then area between the curve is this part. The area between the curve is going to be this part. Is that okay? So once you sketch your graph, you want to find out the area between the graph, then you say, okay, well, that's just integration. The way to do it is always from A to B of the top graph minus the bottom graph. And usually it's dx. Now, at times, you might have to deal with another situation. If it's a horizontal orientation, then it's going to be C to D of right minus left dy. So the right minus left. But for 90% of the case, it's top minus bottom. Only in 10% of the case, I'm going to throw you here curveball, see if you guys can find it. Is going to be right minus left. So in this case, the top function is going to be from 0. Well, we're going to start at 0 to 1. So 0 to 1. Is that okay? And top is going to be x squared plus 2 minus negative x dx. Even though it's negative x, it's still subtracting. So in this case, it becomes adding. So it'll be x squared plus x plus 2 dx. Which is you can find out as x cubed over 3 plus x squared over 2 plus 2x between 1 to 0. Then it's going to be 1/3 plus 1/2 plus 2 minus 0. And that's equal to 17 over 6. So that'll be this area here, 17 over 6. Any questions? It's good? Fairly easy? Can I move on? All right, I'm moving on. Okay, so this time it's going to be a little bit different. This one says, hey, can you find the area between the curve? But in this particular case, you don't know where the bound. So unlike previous question, the bound is between 0 and 1. So it's really easy to define that because we give you two separate equations, is x equal to 0 and x equal to 1. In this case, we know that there's two functions. One function is a parabola. One function is a straight line. Now, how do you find the area between the curve? Okay, so our goal is find area between the curve. How do we find the area between the curve? Yes, you have to find out where the intersections. Because if you find out where the intersection is, then you know the A and B from what bound to what bound. So can you do that?
Are we just finding the intersections, or are we going all the way?
Why don't you go all the way, find the area between the curve. First of all, try to sketch that graph though. Because if you sketch a graph, you might be able to, if you graph it accurately, it should be enough to able to find intersection without using algebraically. But yes, you should find it algebraically where the intersect is. If you do it right, you should get 4.5. Right, I got right. Nowadays you get 4.5. 9/2. Fraction would be 9/2. Okay, so I'm gonna start sketching this graph. We know negative x squared is a parabola facing down. So it's 2 parabola facing down. So it's like this. If you graph correctly, it should look like this. And x should look like this. Oops, this is wrong. This point is right. If you graph correctly, it should look like this. So basically, you want to find an area like this. It's a vertical slice. Each slice is gonna go in from, well, we don't know what a boundary is. Algebraically, you can set two equations equal to each other. So you can find out where they intersect. So it'd be x squared plus x minus 2 equal to 0. And here it's gonna be x plus 2 and x minus 1. So x equal to -2, x equal to 1. So therefore, this one is going to be a -2, and this one is going to be 1. So you know integration is going to be -2 to 1. Now it's going from left to right when you count them, right? So the top function is going to be 2 minus x squared minus x. So now I'm going to integrate this. So it'll be -x squared minus x plus 2 dx. Which is equal to -x to the 3 over 3 plus x minus x squared over 2 plus 2x between -2 and 1. Am I doing okay? Aiden, are you following me? Okay, that's equal to -1/3 minus 1/2 plus 2 and a minus -2 to the 3 minus -2 to the 2 over 2 plus 2 times -2. Now what I will do is I will actually simplify this particular way because I have a same denominator. So that means this is going to be -1 over 3 minus 1/2 plus 2 minus this one's going to be -8 over 3. This one is going to be minus 4 over 2 and minus 4. Now, I will actually combine this way because I feel like a lot of times, especially you have multiple different fractions, this will be easier because wait, hold on a second. This one is going to be, this one's +8, right? This one's 8. I made a mistake here. So if I have -1/3 subtract 8 over 3, if I subtract them, distribute them, that's going to give you -3. Is that okay? Because you got -1/3 subtract 8 over 3 because they have common denominator. So I can just subtract them. I don't want to combine each time. And also I here I'm gonna be plus 3 over 2. This term is gonna be plus 3 over 2. And last term is gonna be plus 6. So that's minus 3 plus 1.5 plus 6. So that's equal to 7.5 minus 3 is equal to 4.5. So my answer is 4.5. You guys good? Ignacio? Good? Aiden? All right, so the next one's a little bit more difficult. Or a little bit easy. I don't know, depends on how you look at it. So I got this two functions. Y equal to x cubed and equal to and y equal to x. I want to find the area between the functions. Between the functions. So you might want to draw it first to see this. And you might need to find intersections first because you'll find something that is different than before. Now, if you graph it, you'll find out how many area there are. How many area between the curve? Two pieces, right? If you see that's two pieces, then and it turns out they are symmetrical pieces, it makes a lot easier. So this, it's gonna be like this, and this will be like this. So we are gonna figure out the area between those two functions. The area is not negative. You got areas negative is bad. So that's the graph will look like. However, you say, okay, well, if the graph look like that, it's not 0. Because top and bottom are different. So you want to look at between x cubed equal to x. X cubed minus x equal to 0. If you factor out x, it's going to be x squared minus 1. And that's going to be x plus 1. And x, it's 3 zeros. So obviously you got a negative 1, 0, and a 1. Sorry, this is a 1. This is negative 1. So then let's take account into first area first. The first area, the straight line is on the top. So be x minus the x cubed. 0 to 1. Is that okay? Because that's what happened to the first function. Otherwise, you get negative area, then that's bad. Also, you can do plus integration from negative 1 to 0. Now, the other function is going to be on the top this time. So this is a long way to do it. Now, for me, I will do a shorter way because since they are symmetrical, I hear like Jenny was talking about they are symmetrical. You're absolutely right. So symmetrical, so can I just say 0 to 1 of x minus x cubed dx times 2. Right, this is the same thing. You're gonna find out the answer for this one. It's gonna be 1/4 plus 1/4, so it's 1/2 anyway. But if you do it this way, it's gonna be save you half amount of work. So then you say 2 between 0 to 1, so that's gonna be 2 times x squared over 2 minus x4 over 4, and between 1 to 0. So it's going to be 2 and 1/2 minus 1/4, which is 2 times 1/4, which is equal to 1/2. So both areas 1/2. Add together is 1/2. Each area is 1/4. If you do it individually, you're going to get 1/4 for each. And then, yeah, so your total answer should get 1/2. Yes. Because they are symmetrical. On the left piece and right piece are symmetrical. So I can just do integration 0 to 1 times 2. Now that's only work with symmetrical though. You guys are good? Okay. Next case is a little bit different. Next case is I'm gonna give you sets x equal to 3 minus y squared and x equal to y plus 1. Now you never seen this in the past. You seen y equal to 3 minus x squared, you see y equal to x plus 1, but you never see the other way. It says x equal to 3 minus y squared and x equal to y plus 1. This is right minus left. Yes, this is the right minus left situation. Yeah, switch it makes more complex, but yeah, switch it, you had to do 2 integrals. All right. So in this case, I'm gonna guide you through it on this one because you have to do it in terms of y perspective. You cannot do it in terms of x perspective. But first of all, how do I graph 3 minus y squared? Well, how do I graph 3 minus y squared, guys? What do I do? Three minus y squared. What does the graph look like? It's a sideways parabola from 3. Yeah, you can plug in y0. If it's y equal to 0, it's going to be 3, right? So it's going to give you this, right? Now, negative y squared, if positive y squared is facing the right side, negative y squared is facing the left side. So it's going to be like this. So the graph's going to look like something like this. Okay, so this one is going to be a plus 1. So it's going to be right here. And it's going to be a x here. So now there's a between the blue line. Now, if I do it in x perspective, I'm going to have to do 2 sections. Actually, not only do you have to do 2 sections, you're going to have to do a lot of changes. If I do it in terms of this, you're going to have to stop right here. Why do we have to stop right there? Because this top function and bottom function are the same. They subtract each other, it's going to give you a 0. But it's not 0. So you cannot break this to 2 parts. So I will prefer you to do is draw a different type of rectangle. So which is this way. Why is this way better? Because you only have to do 1 integral instead of 2. So it's going to be right minus left. But from what value to what value though? From what? -2 to 1 is the y value. Do you see this? This is a y equal to -2. So it's going to be 1, -2, sorry, to 1. What's the right function? 3 minus y squared minus y plus 1. Y plus 1. Now I'm going to distribute it. Now why is it -2 though? Remember, you're doing integration from this part to all the way to here. In your homework, you had to do a two perspective. Well, I will talk about it in the homework in a second. So let's just say -2 to 1. 3 minus y squared minus y minus 1 because I distribute. If I integrate this, and I'll do that adding fraction, subtracting fraction, I will get something like, say, it's 9/2. Same as a question ago. Now, if you do it in terms of x perspective, it makes it a lot harder. Why it makes it a lot harder? Now, just do it in terms of x perspective. You're going to have to cut it this way. And it's top minus bottom, so you had to solve for that. So in terms, if I do it the top minus bottom, it'll be the red line. The red line is y is equal to x minus 1. So in terms of the other one, it's going to be y squared is equal to 3 minus x. Y equal to 3 minus x plus minus. So this one will be x minus 1 minus, and it's going to be the x minus 1. It's going to be minus negative square root 3 minus x. Why is it minus? Because top minus the bottom, right? But the bottom, you have to use the negative side of the parabola. So that's why it's kind of complex. And that's between from here to here, from -1 to 2. So -1 to 2. Now, that's only take account into this specific area right here. You do not take account into this area. How do I take account into that area? Was adding from -2 to 3. The top function is going to be 3 minus x minus -3 minus x dx. Now, if you did this work, you're going to get also 9/2. But just a lot longer. Yes.
Maybe, but why can't you just do from 2 to 3? If we're just adding that last level.
Yeah, 2 to 3, but it's top function minus bottom function. The top function is square root of 3 minus x. That's a positive. Or the bottom function is going to be a same function, but it's a negative version of it. So it'd be minus negative square root of 3 minus x. You can do -2 to 3 and the 2 in the front, square root of 3 minus x. You're going to get the exact same thing.
So I understand from -1.
Oh yeah, this one should be from 2 to 3.
Okay.
So if you do it in terms of x perspective, the x domain is different than the y range. Okay. All right. Shh. Now I want to give you a really good instruction to help you save a lot of time on your homework. In your homework, you should do it in terms of x perspective and y perspective. You should not do the calculation by hand. You should use decimals to do it to set it up, see if they come up the same. Your goal is to come up the same. But not every question you can use horizontal things. Every question you should try both way and should come out the same answer. Yes. Yeah.
Or just to check.
I don't want you to do calculation because you know how to do definitely, bro. Like last year I will want you to do it because you need to experience how to do a one fraction subtract another fraction. And you'd be surprised, this year a lot of kids don't know how to subtract fractions. Yeah. They don't even know how to multiply fraction.
You know what that means, Fiona? Only gonna work 2 days.
You don't have to work today? You don't have to work?
Can't. I only gonna work 2 days. Cause Tuesday, wait. Tuesday, Wednesday, because I already worked today. Tuesday, Wednesday, I start all week. And then Thursday and Friday, because I'm going to be. And then Saturday I work and Sunday I can work.
Don't stop. You're gonna mark earthquake down. I'll look at it. I'll look at it. That's Brandon. You're just bad.
Yeah, he stops when he's just doing nothing. He'll go like this and then.
That's what he needs, right?
The one guy that you playing with, Steven.
Yeah. I know. He taught me how to return everything. I never not return everything. It's just wherever the paddle goes is where the ball is going, so you just push the other way. So if it goes like this, you push this way, and it'll go. I couldn't know. I was playing. I couldn't return it in, so I was so like confident because what? He's like, he looks like a dad, like 40 or something. I thought he was gonna suck. No, he's a white guy. I thought he was gonna suck. He just looked like some dad that just plays ping pong sometimes. And like he wasn't like that good, so like his serve would be like he does like a pendulum, but then he'd go like that. But he was good though. Like we would step back and get like a good round. I want to buy a paddle for Cyber Monday, but I don't know what to buy. I was gonna buy a butterfly one, but
Butterfly is really expensive.
they only put discounts on the ones no one wants.
Butterfly